Hi guys, let's do find lucky integer in an array. So we're given an array of integers, and a lucky integer is an integer that has a frequency in the array equal to its value, and they want us to return the largest lucky integer in the array. And if there is none, then they want us to return -1. So in this example here, we would output 2 because the only lucky number in the array is 2 because the frequency equals the number itself, right? So we have two 2's, and then 2 is equal to 2, which is the number itself, so we return 2. In example 2, we output 3 because all of these are lucky numbers because we have 1, 1, 2 2's, and 3 3's. So each one of these is a lucky number. But because there's multiple, then we're going to return the largest one, which in this case is 3. And in example 3, we return -1 because there's 3 2's and 3 3's. So since neither of these numbers' frequency equals the number itself, then there's no lucky number, so we just return -1. So to do this problem, we're going to want to store each of the numbers mapping to their frequency so we can check if they're equal or not. So we're going to do that with a hash map. So if we use this as an example, or I guess let's actually use example 2 because it's a little bit more, like there's more going on here. So in this example, then if we build out our map, we're going to start by initializing it as empty, and then we're going to loop through this array. So then when we get to 1, we're going to check if our map has a 1, and it does not. So we're going to add 1 with a frequency of 1. And then 2, we do not have a 2 yet, so we're going to add 2 with a frequency of 1. And then when we get to this 2, then we already have a 2, so we're going to increment that to 2 for the frequency. And then we get to 3, and then we do not have a 3, so we're going to map 3 to 1. And then at this 3, we already have a 3, so we're going to just increment this by 1. And then at the last 3, then we're going to just increment this again to 3. And then we've reached the end of the array, so that is our final built out map for this example. And then, but they want us to return the largest lucky integer. So we're going to need to keep track of what our current largest lucky integer is, which we will say is like our maximum. So we can say a max, and then we can initialize it to just min value. And then when we go through here, so we're going to check, first of all, we're going to check if each of these numbers equals the frequency. And if it does, then we're going to want to update our max with either the current max or the new number, whichever one is bigger. And if they're not the same, then we're just going to skip it. And then at the end, then if we go through the entire array and there's nothing that is a lucky number, then we're going to just return -1. So let's start by building out our hash map. And then we're going to loop through the array and add each number and its frequency into the map. So yeah, we're going to just add this number and increment the value by 1 if we have it, or set the value equal to 1 if we do not have that number already. Okay, so then that's going to build out our hash map just like this for that example. And then now we're going to want to loop through the map, updating our max as we go. So we're going to loop through the keys because then we can just get the value using the key. So if the number, right, because that's the actual key, is equal to the value, which is if we get that map.get that value, then we're going to update our max with our previous max and this new number. And then we're just going to do that for every single number in our map. So once we get through the entire thing, if there was nothing, then our max is still going to be min value. So if our max is still min value, then we'll just return -1. Otherwise, we will return our max. So let's check that. Okay, perfect. And then let's go over the time and space. So then I'm going to move this so we can see. And then our time here is O of n, where n is the number of elements in our array. So as you can see here, we have two different loops going on here with that one and that one. And so in the first loop, we need to visit every single number in the array in order to put them into the map, whether it's a new one or one that we already have to increment it. But either way, we still need to loop through or visit every single number in our array. And then in the second loop, we are iterating over our map. So worst case, if every single number in here is unique, so like in example 3 here, or no, not unique, sorry. I guess not example 3, but like let's say every single number is unique, then we're gonna have to store every single number in our map with a count of 1. And so either way, like our map would still have O of n in that in worst case for that, so that's still O of n. And then our space complexity is O of n as well, because let's see here. So we only have this hash map as our only data structure here, and in our hash map, so again, worst case, if every single number is unique, then we're gonna store every single number in the map with a count of 1. So that's our worst case space complexity. So that's it for this problem. Thank you guys for watching, and let me know what problem I should do next. Bye!